Hello everyone, welcome back to my class. This is the third session on the ongoing solution series of 2020 JAMB past question. So in our last class, we stopped at question 20. So we're going to continue from question 21 today. So the first question here, which is question 21, says, a ray of light is incidented on the surface of water at an angle of 30 degrees. This is angle of incidence. Calculate the deviation of suffered by the ray in water. Calculate the deviation suffered, that is angle of deviation suffered by the ray in water, given that the refractive index from air to water is 1.33. So without wasting time, in exam setting, what should come to your mind is that refractive index is equal to sine of angle of incident all over sine of angle of refraction. So, and also that angle of deviation is equal to the angle of incident minus angle of refraction. Please take note of this. This is what should come to your mind in exam settings. So since this is the fact, we are given angle of incident to be equal to 30 degrees. So let us calculate the angle of refraction, given that the refractive index is equal to 1.33. So from this formula, refractive index is equal to sine what? 30 degrees all over sine r. So let's put the value of refractive index, that is 1.33, is equal to sine 30 degrees all over sine r. So let us cross multiply. That will give us sine r multiplied by 1.33 to give us 1 multiplied by sine 30. Sine 30 is 0.5. So that will give us, this implies that sine r, by the time we divide both sides by 1.33, we have 0.5, all divided by 1.33. So sine r will be equal to, when you divide 0.5 by 1.33, you will have 0.3759, right? So here our R will be equal to sine inverse of 0.3759. Clear? Remember, I told you that you have to be fast and smart in exam. So sine inverse of this, that should give us, when you press sine inverse of this, let's check in your exam. I think you have calculator, but there is no sign. So in exam setting, how do we get the sine inverse? That is where the issue is. Okay. It's all right. Let's assume that it's available for us, but I will look at how we'll be able to get through such a situation. It's not always like that. So sine inverse of this, that should give us 22.1 degree. 22.1 degree. Therefore, the angle of deviation, which is equal to angle of incident minus angle of refraction. The angle of incident is 30 minus angle of refraction, 30 degree, which is, refraction is 22.1 degree. When you do that, you're going to have 7.9 degree. Approximately, you have 8 degree. So the correct option here is option what? Option A. I hope this is understood. So that is about this question. So the next question is question 22. Question 22 says, a person with maximum distance of vision 10 centimeter uses a diverging lens of focal length 15 centimeter as a magnifying glass. What is the magnification when the lens is held close to the eye? So here, since magnification here can be linear magnification or angular magnification, but since we are dealing with an application, right, which is a magnifying glass here, unlike if it is if the light is incidented on a plane surface, we'll be talking about linear magnification. But because an instrument is used here, the magnifying glass, so we'll be talking about angular magnification, capital letter M, that is angular magnification. So this is what we're talking about here, please. It's not linear magnification. So the person with maximum distance of vision, that is the least distinct vision, right? So meaning that the closest distance that the person can see for a normal eye without defect, right, is 25 centimeter. That is the near point, is 25 centimeter. But here, the closest distance of clear vision by this particular person is 10 centimeter. So given that D, which is the same thing as the maximum distance of vision, that is maximum distance of vision, which is the same thing as the near point of the person. So the near point, or either the closest distance of a clear or distinct vision. So that is the near point. And the value D is said to be what? 10 centimeter, right? And also, we are given that the focal length of the magnifying glass F is equal to it is a diverging lens, isn't it? Use a diverging lens of focal length as a magnifying glass, right? So the diverging lens is used, therefore the focal length is going to be negative. So we have minus 15 centimeter, right? So we are asked to calculate the magnification. So we're looking for the magnification. The unknown is the magnification here. So in this case, we make use of this formula. The angular magnification, capital letter M, is equal to 1 minus D all over focal length. This is for divergent lens. This is for divergent lens. Exactly. So from here, we have our magnification equal to 1 minus D, which is 10, all over minus 15. This will be equal to 1 plus 10 all over 15. So if you do the LCM, this will be 15. 1 in 15, 15 times 1, that will give us 15, plus 15 in 51, 1 times 10, that will give us what? 10, which will be equal to 25 all over 15. Therefore, angular magnification is equal to 5 in 25, that will be 5, and 5 in 15, that will be what? 3. So the correct answer here is option what? D, which is 5 all over 3. Are we together? So this is how to tackle this type of question. It is not linear magnification, rather it is angular magnification. So the next question is question 23. So question 23 says, the diagram in the figure above shows the lens arrangement in A, compound microscope, B, an astronomical telescope, C, binocular, D, periscope. So you can eliminate option C and D if you know anything about combination of two lenses. So if it is a compound microscope, it has objective lens and an eyepiece. The eyepiece has a larger focal length, while the objective lens has a smaller focal length. So they are not the same. But this one now you can see the lenses are the same. Therefore, the correct arrangement here is for an astronomical telescope. Is that understood? So question 24 says, A poster has a red letter P on a white background. When it is viewed through a blue transparent screen, an observer will see a magenta P on a blue background, B, magenta P on a blue-black background, C, black P on a blue background, and C, black P on a greenish-white background. This we have basically primary color of light, which are what? Red, blue, and green. So the way it is that, for instance, the red light will absorb all other color and only what? Reflect red. Same goes to what? To blue. It will absorb all other color and reflect only the blue color. Same goes to what? To green. So the letter red, the red letter P, on going through a blue transparent screen, it will be absorbed by what? By blue transparent screen, because blue transparent screen will only reflect blue color and absorb all other color. And when this absorption takes place, this letter will appear as black. Is that clear? Now, the white background reflects all colors. So, and in this case, the blue screen will only let blue to pass through. Therefore, the white background will appear to be a blue background. So the background will be what? Will be blue. So therefore, the letter will be black on a blue background. So that will give us option C to be the correct answer. So moving to question 25. 25 says, which of the following colors of light will give white light on mixing? Now, A, we have red and yellow. B, red and magenta. C, magenta and green. Yellow. D, yellow and green. If you know color triangle, you know that red plus blue gives what? Gives magenta, right? And white light, if mixed, right? If all the three colors, your red, blue, and green are mixed in a normal proportion, it will give us white light. Take note. Is that clear? So now, since red and blue give us magenta, therefore, magenta plus green will be equal to what? White. Therefore, the correct option here is what? Magenta and green. It's very simple. Red, blue, green, if mixed in a good proportion, it will give us white light. Magenta is a summation of what? Is the mixing of what? Red and blue color. So that is why magenta plus green give us what? White. Exactly. So that is question 25. 26 says, as a positively charged rod is brought nearer to the cap or to the top cap of a positively charged gold leaf electroscope, the divergence of the leaves will be what? A, increase to 0, B, steadily increase, D, decrease to 0, C, remain constant. You should know that the principle on which gold leaf electroscope works is the principle of, or the law of electrostatic, right? Like charge repel, unlike charge what? Attract. So from what we have here, the gold leaves is already charged positive, right? So the leaves are apart. And when a positively charged rod is now brought near the cap, it pushes more positive down to the leaves, thereby will cause what? More divergence, right? Therefore, we can now say that when this happens, the leaves will diverge, steadily increase. More divergence, meaning that it increases steadily. Is that clear now? So that is charging by induction. In the process, it was charged by induction. So question 27, we have this circuit. Here we have capacitors in parallel. one in series connected to two other one in a parallel. How do you know that a certain either capacitor or resistor are in parallel? When they are arranged side by side, we say they are in what? Parallel. So we can rewrite this, redraw this. So this is the first capacitance. We call it C1, and the value is 6 microfarad. Then connected to another arrangement of capacitors of capacitance 5 microfarad and 7 microfarad. They are in a parallel. And let's call this one C2, having a value of 5 microfarad. And this one, call it C3, having a value of 7 microfarad. This is connected to maybe to a voltage, or the case may be. So when you have something like this, always go for the what? First of all, go for the ones in a parallel and sum them together. So when capacitors are in parallel, the equivalent capacitance, we call it C1, comma 2. Here is 2 and 3, so we call it C1, C2, comma what? 3. That is combination of the capacitance C2 and that of C3. So since they are in parallel, it's just a direct summation. So that would be C2 plus what? C3. This one will give us 5 plus 7, which is equal to 12 microfarad. Exactly. So our new circuit can now become something like this. The whole of this has become 1. So it now bear a name C2, 3 with a value of 12 microfarad, as simple as this. So here is our C1 and the value is 6 microfarad. Now, since they are in series, we can now say let the total capacitance, let it be CT. That's what we're now looking for. So when capacitors are in series, we use this formula, which says that 1 over C total equal to 1 over C2 plus 1 over C3 plus C1 here, C2, 1 over C3, and so on. Therefore, in this case now, we can now come and use that formula to find our C total. That is going to be 1 over C total will be equal to 1 over C1 plus 1 over C2, 3. This implies that 1 over C total is equal to 1 all over C1 is 6 plus what? C2, 3 is 12, right? If you find the LCM here, that will be 12. 6 in 12, that will be 2. 2 times 1, I have 2. Plus 12 in 12 is 1. 1 times 1 gives us a 1. Therefore, 1 over C total is equal to what? 3 all over 12. If you cross multiply or find the reciprocal of the value, our C total will be equal to 12 all over 3, which is 4 microfarad. Exactly. So that is about question what? 27, and that is option B. Exactly. So moving to the next question, which is question 28. Question 28 says, the point at which the resultant magnetic flux density is 0 is called the neutral point. Please take note of this one. This is a direct question. The point at which the resultant magnetic flux density is 0 is called a neutral point. The next one is question 29. Which of the following statement is correct about the Earth's magnetic field? So A, the angle of dip is the angle which relates suspended magnet makes with the vertical. No, that is wrong. The others are magnetic element. The angle of declination is the angle between the magnetic meridian and geographic meridian. That is the correct option. Right? Please take note and understand the difference between your angle of dip, angle of declination, horizontal and the vertical component of Earth magnetic field. Is that clear? So the next question is question 30, which is the last question for this session. The question says, a simple cell with mercury amalgamated zinc electrode prevents A, local action, B, polarization, D, buckling, C, degradation. The correct answer here is what? Local action. Local action is due to occur as a result of an impure zinc plate. So this one causes the plate to dissolve even when the cell is not actually dissipating energy, right? So this can be prevented by a kind of rubbing the plate with some mercury amalgam. And this process is known as amalgamation. Are we clear? Another defect of a simple cell is polarization, and this occurs as a result of hydrogen bubble formation on the electrode, precisely the copper plate. And also, this can be prevented using what is known as a depolarizer. And the one mainly used is known as manganese 4 oxide. Exactly, that is for polarization. Please take note of this. It can also come in the form of theory. The two defects are local action and polarization. So we are going to stop here today and continue from here in our next session. Please, if you have any questions, please let me know on the comment section. I'll take it over from there. Thank you for your time. See you in the next class.